In case of low level language, we have got some very minimum abstraction from the hardware. That means it is very close to the hardware, and we have got some direct control over the system resources. Due to the factor that it is very close to the hardware is the only reason that we have got some very significant control over the system resources directly. Now, there are two types of the low level language. Number one is the machine level language, and the second is assembly level language. So let's understand the machine level language first. So in case of machine level language, it is very lowest level of the computer language, and here the set of binary codes represents an instruction. That means 0, 1, 1, 1, 0, 1. All this stream of binary information creates one significant meaningful information for the computer, and computer can directly execute this machine level language. Now let's understand this example. For this example, as you can see that stream of bits, now this information may not be seems to be meaningful for us, but this information may be meaningful for the computer system. How? Suppose the first segment of information representing a code, the second segment of information representing operand 1, and the third segment of information representing operand 2. Now this is just an example. For a real scenario, specific meaning of each part can be different because it is completely depends on that particular target system's instruction set and the computer architecture or the processor architecture. Now, one most important point for the machine level language is programmer rarely use this machine level language. Why? Because it is very complex to understand and the lack of readability is also there. The low level language is very fast to execute. Why? Because this is a very raw binary information that we already have mentioned, and due to the same reason no interpretation is necessary by the machine, so it can directly execute. Machine level language is not portable. Now what is the meaning of this not portable? Not portable means it is machine dependent. That means whatever the code, suppose this raw binary information is completely designed for any particular system. So if we just try to write this code for any particular system, we won't be able to run it for any other system. It is completely written for that system only. We cannot just run it in any other system because of the processor architecture is maybe different. They may not be able to interpret this code. Now let's understand the assembly level language. So in case of assembly level language, we have got some added advantage or added benefit over the machine level language. So now we have got some better readability than that of machine level language here, and it provides some better abstraction over the machine code. The assembly level language, it is just not the raw binary information. Because of this is not a raw binary information, we are not going to execute it directly by the machine. Now why this abstraction? Because of we are using mnemonics, symbols to represent instruction and operands. So this is not just binary information. Now let's understand one example of assembly level language. Here, as you can see, we have mentioned that this is an example for x86 assembly. Now what is the meaning of it? The x86 means that this is completely representing one particular kind of architecture. That means the x86 processor architecture. For this x86 processor architecture, we are going to run assembly level language. Now the MOV EAX5, it has got some significant meaning to it. It is just telling that this instruction is aimed to move this value 5 to the EAX register. For the second instruction, as you can see, the add as the opcode here, and EAX is also registered here, and the value is 3. That means whatever the value is already residing within this EAX register, just add 3 to that particular value. Now this move and add, for assembly level language, we are going to call it the mnemonics. And for this EAX are a particular kind of register within the x86 assembly or x86 processor architecture. Now this 3 and 5, we already know that this is the very numeric value. Now with this example, as you can see that there is no raw binary information we are writing over here, and there are better readability than that of machine level language is there. Now as the assembly level language is just not the raw binary information, then how the machine is executing it? So definitely we need some kind of translator here, right? Let's understand how it is working. So here, as you can see that here the assembly level language like move, add, these are the instructions or these are the mnemonics. If we give them as input to the assembler, then the assembler can easily translate them to the machine level language like 0, 1, 1, such kind of binary information, and now the machine can easily understand it and execute it. Here this assembler is working as a translator. Assembly level language is very machine dependent. That means like this instruction, if we can say that this instruction particularly written for x86 assembly, That means if there are any other processor with different architecture, they probably won't be able to run this instruction because they have got their own kind of instruction set. They have got their own kind of instruction format. So this is the only reason this is very machine dependent. Due to the fact that this is very machine dependent and it is particularly written for that target system, it is also fast to execute. As I already have mentioned that a very little amount of abstraction is necessary. That is the only reason the assembly level language has got some significant faster execution than that of high level language, but not faster execution than that of machine level language. Due to the fact that it is very fast to execute, we use it to write device drivers, kernels, etc.